Hey everyone, welcome to my channel. It's the code terrain. We're going to be solving a simple LeetCode problem. Let's take a moment to review the problem statement. So it says employees earning more than their managers. So we have been given a table called employee. So it consists of four columns with its respective data types. So the question says that ID is the primary key for this table. Now, when I look into this example of employee table, I can see ID to be having the unique identifiers, the primary keys. And it says each row of this table indicates the ID of an employee, their name, salary, and the ID of their manager. So the question, so here's the real part. So it says, write a solution to find the employees who earn more than their managers and return their results in any order. Okay, now looking into the table, we have already identified the primary keys. So we've been given the name of the employees. So when I look into the manager ID, it consists of the integer values. So we can say that these values are self-referencing values in a way that the number 3 is going to point towards to the primary key 3, and also the number 4 is going to reference with that of the primary key 4. So what it basically says is that Joe's manager is Sam, since that the primary key is 3, and Henry's manager is going to be Max. So Joe and Henry, both of them, they have their managers that they report to. Sam and Max, it says null. They don't have a manager. So it looks like, they work in a very typical IT world. So they report to the CEOs probably, not the managers, which is why it's null. This is going to be our expected output. Okay. So now, one of the challenging aspects of this problem is that um, we have been given this, objective of finding the employees, who earn more than their managers. So when you look into it, the way we can achieve a solution to this objective is going to be like, through comparison. So the question we have to ask ourselves is, can we really compare the salary of both the employee and the manager in one single table? I mean, look into the salary column. So you have the earnings for both, managers and the employees, like Joe Henry and Sam Max, specified in one single table, and that's going to really put us into big trouble. So what we can do is we can try replicating a secondary table. We can consider this as the left table, and I want you guys to imagine that there is a virtual table towards the right, which carries pretty much all the information that you see it over here. All right. So now how can we achieve this? This is where the concept of self join comes into play. So self join is basically where um, it joins the table with itself. So here we have the employee table. When I'm going to do a self join to this table, it's going to take this table and going to join with itself. All right. So I'll be definitely showing you guys some example in my Excel sheet, so that you guys can have a clear picture of as to what I'm trying to say. So this Excel sheet goes on to display an excellent illustration between how these two tables merge and couple with each other. And again, this table is a resultant table from performing operations like join that we are about to do. And the one that you see it on the left, which is the yellow color table. And this is going to be the default table that you would already see it in the question. And then we also have the virtual table. Again, this was discussed earlier. So we basically need these two tables sitting next to each other, so that it makes our entire operation of doing the comparison and finding the greater salary, between the manager and the employee is going to be like really easy. Else, it's really going to put us in a tough spot. Now, let's try to get into writing some codes so that we may have some better chance of understanding how these logic flow and how two tables interact with each other. All right. Selecting all the informations, all the columns for now. During the final run, we'll go ahead and do the specific column selection. But for now, I want you guys to see how we can generate different outputs before we arrive at the final result. So from employee table, the first instance that we're going to create, like the first table, we're going to alias this as E. So E denotes the employee table. We're doing a self join for the same employee table, and M denotes that this is the manager table. So this is how it's going to look like: the employee table on the left, manager table on the right. But in the real world example, you're going to be seeing a Cartesian product. So basically, you're going to see the combination of both these tables, with one row trying to match with the rest of the rows of the virtual table. It's going to result a Cartesian product. You're going to have like 16 rows into this. But anyhow, let's not try to confuse ourselves. We'll just stick on with this example for better understanding. So now that we have two tables that sits, next to each other, we our goal is to basically try to really extract the employee information onto the left and the manager information onto the right, because here in this table you see both the employee like Joe and Henry, which is also included with Sam and Max. So we don't want Joe and Henry, right? So yeah, this can really be done with the help of the foreign keys and the primary keys. We have already identified the primary keys. So we also have the primary key column under the manager table. So what we're going to do is, so far until about we wrote this query, um, the values that you see it under the manager ID, right? So the values that you see it over here, these values were considered to be the self referencing values so far. And why is that? Because we only had this one single table, and foreign keys never really comes into picture, um, unless we have a secondary table. But now that we have two tables, two instances, these self referencing values are now going to act as foreign keys. As you guys know, foreign keys are very good at establishing relationship with the secondary table, which is what it's going to happen now. And yeah, it's also going to check if the values that are going to be present within this foreign key column itself, and it will check if it is also going to be present in the primary column of the manager, right, manager table. So we'll now write the condition, so that uh, we can really have the foreign keys targeting the primary column, right? So for that, we are going to be writing a condition under the on clause. So the condition under this on clause, so you have onto the left the foreign column of the employee table, and then you have the primary column consisting of primary keys of the manager table. So what this condition now is going to do is, the foreign keys under the foreign column will be targeting the primary column of the manager table. So here the number 3 matches with the primary key, and also the foreign key 4 matches with the primary key 4. So what this one says is, whenever the matching happens and the condition gets satisfied, the employee Joe over here will right now have the information of his manager Sam being populated right next to this table. And similarly, it's going to happen for the employee Henry. So this is how it's going to look like, after having used that condition. Also, the join type that we have used here is the self join. So self join, naturally they're going to exclude the null values. And if at all there is a case or a necessity for you to be using the inclusion, like if you want to include the null values, you can go with the left join. But again, for this particular problem, what we are doing is we are trying to match the employee salary. We are trying to compare it and see which employee is earning more than its manager. So since that Max and Sam do not have any managers in them, we can just exclude them, and we'll go with the self join itself. So we now have the information of the employee beautifully segregated onto the left, and also we have the manager's information onto the right. Now, with that being said, the comparison of the salary and finding which employee earns more than their managers becomes way more easier, right? It's much more feasible. Now, let's write the query, for the salary comparison. So let's go with the where clause. This is a filtering condition. We want to check if the employee salary is greater than the manager's salary. So what this condition is now going to do is it'll now check if Joe's salary 70,000 is more than Sam's 60,000 or not. All right. So in this case, only Joe, the employee Joe, seems to have, the greater salary than that of their manager. So we'll try running this query and see how the output gets generated. Okay, now we have the answer very closer to the expected output. But the thing is, we both have the employee information as well as the manager information, right? So we are going to now modify the select statement so that we just grab and obtain the name Joe alone. So here, what we're going to do now is we want to select the employee name from the employee table. So e dot name, I'm aliasing this as the employee because that's what it says over here. That's the column name. So now let's try to rerun the query. So our solution got accepted, and we do have the expected result as Joe. Anyhow, guys, I hope you enjoyed this tutorial. So if you did, please do like this video and subscribe my channel. And yeah, hopefully I'm looking forward to meet you guys in the next video.